Portable battery system. Today, I'll talk about the portable battery system and its usage on a parallelized program. The portable battery system is a battery queuing system that performs job scheduling. Its primary task is to allocate a computational task among the available computing resources so that the computational resources are balanced efficiently. When you submit a job to the batch queue, it is scheduled for execution on one of the cluster nodes. This scheduling process considers parameters such as machine load and available number of the core in deciding. Typical batch queuing system schedules jobs for execution by a set of queue controls. The controls determines the queue from which jobs will be selected. Within each queue, jobs are typically selected in first in, first out order, and this limits the set of scheduling policies available to a site. The portable battery system removes this limitation by providing an external scheduling module. This separation program has full knowledge of the available queue job, running jobs, and system resources usage. Policies may range from best fit to fair share using various algorithms. Scheduling decisions can be made over the full set of jobs regardless of queues or orders. The scheduling policy can be changed to fit a wide variety of computing environments and scheduling goals by users' explicit data mapping. The portable battery system software was developed by NASA Ames Research Center and the Lawrence Livermore National Laboratory. Before the clusters, the Unix-based network queuing system were used in an interactive manner. Background jobs just proceed with their input disconnected from the terminal. With the emergence of parallel distributed system, the need to be able to schedule tasks based on available resources increased in importance. The advent of network servers, smaller general systems, and workstations leads to the requirement of a networked batch capability. The PBS system is to provide additional controls over initiating or scheduling execution of batch jobs, and allow routing of those jobs between different hosts. The batch system allows a site to define and implement policy as to what types of resources and how much of each resources can be used by different jobs. PBS is available in 3 versions: OpenPBS, Talk, and PBS Pro. OpenPBS, open source version of PBS, became the new name of the PBS Professional Open Source Project, which offered by Altair Engineering. Talk is a fork of OpenPBS. PBS Pro is a commercial product offered by Altair Engineering. OpenPBS is recently released the last version, and Talk and a PBS Pro can be converted from this version too. OpenPBS and Talk is open source. These are free to obtain and have multiple vendors. Furthermore, source code is freely available to users for reference, debugging, modification, extension, and controlling its specifications. This shows the flow of information on single host. PBS comes with 4 daemon processes: the job server, the resource monitor, the job execution server, known as MOM, and the scheduler. The first 3 daemons are similar to other batch programs, but the 4th daemon is the new capability. The flow of information on multi-host is the same on single host, but there are multiple daemons which can be allocated a job by scheduler. PBS is mostly used with MPI because the batch queuing system runs the parallel nodes, but each node runs sequentially. Therefore, PBS is suitable for MPI, message passing interface, which is based on distributed memory. User can set each node running own threads. However, this doesn't mean the PBS provides the illusion of globally accessible shared memory. This means that each node has their own shared memory. Users can explicitly map data to a distributed memory, but PBS can provide data mapping. There are so many different job schedulers, such as Linux cron, round robin, and Scrum. The main difference between those and PBS is that PBS is the batch queue system with external module. This external module allows PBS can handle parallel system unlike others. Pros: scalability. PBS can support millions of cores that fast job dispatch and minimal latency. Policy-driven scheduling. PBS meets unique site goals by balancing job turnaround time and utilization with optimal job placement. Resiliency. PBS includes automatic failover architecture with no single point of failure. Therefore, jobs are never lost and jobs continue to run despite failure. Flexibility. PBS simplifies administration with enhanced visibility and extensibility, and allows users to customize implementation to meet complex requirements. Monitoring. PBS automatically migrates failure with a comprehensive health check framework. Cons: network dependency. Without connecting external module, PBS is just a typical batch queue system. Therefore, users need to know how to set the daemons and understand network flow, such as setting root back address. Lack of guide. Due to low popularity of PBS, it is really hard to find a guide for installation and how to use. Non-user friendly. PBS requires high understanding of PBS structure. Not easy to build a job script, and because PBS continues to run jobs despite of failures, users it's not easy to track their failure point. All results are based on 4-core 8 threads Intel i7 CPU, and 100 by 100 matrix multiplication were taken 20 times. This graph shows relation between speedup and threads on pthreads and OpenMP. Based on theory, pthreads and OpenMP should show almost the same result. The result is close to the theory, but OpenMP was a little slow compared to pthreads. I guess this difference occurs due to physical resources. OpenMP is based on implicit thread, which has the ability of the compiler to perform certain operations in parallel without programmer's data mapping. This means OpenMP users can use thread with just importing OpenMP. Pthread is based on explicit thread, which is achieved by the programmers that can spawn as much as they need. In other words, pthread users need to work on data mapping to distributed memory. These features can be found on a code too. This is relation between speedup and thread on OpenMP on Linux kernel, OpenMP using PBS, and MPI using PBS on single host. OpenMP and OpenMP using PBS suppose not to have different results, due to PBS is not the job scheduler for shared memory strategy. I think due to delivery between PBS daemons, OpenMP using PBS is a little slowed down. PBS should accelerate the MPI speed compared to OpenMP, as the reason I mentioned on PBS host slide. I guess due to poor network connection between job server and MOM, and network delays between scheduler and job server, the MPI using PBS has been slowed down. OpenMP is easier to coding and debugging than MPI. Helps user to minimize consideration of data distribution. However, it's only possible multiprocessor environment, and its performance rate depends on architecture, number of processors, and memory. MPI is suitable for distributed memory and shared memory machine, and can support massive parallelism. But it is hard to code and too many works on data distribution. For incremental parallelism requires most sequential code restructuring. All the source code can be found in the Git. Thank you.